All right, let's dive into calculated columns, the first place to use DAX expressions. Now, as you might have guessed, calculated columns, super simple. They allow you to add new formula-based columns to a table, very similar to how we added new columns in Power Query using the query editor. Very similar concept here. Now, a couple things to note. There's no A1 style references here. Calculated columns refer to entire tables or columns. Also, calculated columns are computed row by row, and those values that you compute get stored with the table, which does take up memory. So this is fine if you're dealing with reasonably sized data sets, but if you're working with very large data sets, keep in mind that adding more and more calculated columns will slow things down and eat up that memory. And then third, this is probably the most important bullet of the three, is that calculated columns are designed to understand row context. So they understand the row in which they live. That means they're great for defining things like new properties or attributes based on information in each row. So for instance, looking at a product SKU and calculating the category based on that, but they're generally useless for quantitative types of calculations or aggregations like sums or averages or count. I'm going to show you why that's the case in just a second. Now, big important box here. As a rule of thumb, only use calculated columns when you want to actually stamp static fixed values to each row in a table. Or if you can do the same thing in Power Query, that's even better. What you don't want to do is use calculated columns to try to calculate things like aggregations or to calculate fields that you'd like to use in the values area of a pivot. That's what measures are for, which we're going to cover next. So pro tip, calculated columns are typically used to create fields that you're going to place in the filters or slicers or row label or column labels of a pivot. So these are the types of typically text-based attributes or characteristics that you want to use to filter or segment out your data. Now to create calculated columns, it's very easy. Again, this takes place in the data view in your data model window. And all you do is step one, you select any cell in the add column section, which you'll see on any of your tables. Step two, you enter a DAX function in the formula bar, and we're going to cover specific functions in the next section of the course. And then step three, you press enter, and all cells in the column will update. So what that means is you don't write a formula in each cell. You don't write a formula in the first cell and double click or drag it down. You write one formula that applies to the whole column and it populates in one step. So a little bit of a different vibe than the traditional cell formulas and functions that you might be used to. Now before we dive into Excel, I just want to show you a quick screenshot with a good example of a calculated column and a bad example. So take this case here. Don't worry if you don't understand the formulas quite yet, but these should look very familiar to Excel formulas. In fact, some of them are identical. So in this case, we've created a new calculated column called price category using a simple if statement. So that price category field evaluates to high if the retail price is greater than 2 and low otherwise. Again, this is just like you'd write it in Excel. And because the calculated columns understand the rows that they live in, a new value is calculated in each row based on that particular row's price. So this is a valid use of calculated columns. It creates a new row property or attribute that we can now use to filter or segment any related data within our data model. Now on the other hand, consider this calculated column called total revenue, which is a simple sum function of the revenue column in the transactions table. So here we've created that field, called it total revenue, and because calculated columns don't understand filter context, which we'll dive into in just a minute, the same grand total is returned for every single row of the table because calculated columns just aren't good at aggregation, and measures are going to be a much better fit for doing something like this. So this is not a valid use of a calculated column, and because these values are statically stamped onto the table, we really can't filter or slice or subdivide these numbers. All we're left with is the same grand total in every row, which obviously isn't going to be very helpful to us. So with that, let's jump into Excel, and I want to do a couple demos just to start getting us comfortable with this calculated column environment. Okay, so here we are back in our Food Mart data model, and I'm in the pivot table tab at this point. Let's go ahead and click the Manage Data Model button. I'm in the Data tab now. And here we go. I'm going to start in Data View. And you see this new column that's appeared called Add Column. You'll see this in every single one of our tables as we click through the different tabs. So I want to start by demonstrating a calculated column that's valid. So why don't we go here into our Customer Lookup table and scroll all the way to the end where we'll see this Add Column field. And I can click anywhere in this field, doesn't matter which cell, and select the formula bar to get started. This is where I'm going to write the DAX to produce this calculated column. And for this one, don't worry at all about the formulas we're using. We're going to cover specific formulas soon, but let's say we want to do something like calculate the customer's current age. To do that, we could use something like a date diff function, where the starting date is the customer's birth date. So I can just scroll over until I see the birth date column. And again, I can click any one of these cells, and you see how it populates with the customer lookup table followed by the birth date column. There's no row 14 referenced. There's no column letter. It's just a reference to the table and the column within it. So the date diff function, just as a sneak preview, it takes two dates, a start date and an end date. In this case, my end date is going to be the today function, which is a volatile function that always returns the current date. And the last piece is the interval I want to use. In this case, I want the age in years. So I'm just going to tab and select year and close out the function. And now when I press enter, it's able to see what their birth date was and compare that against today's date with an interval of years. So this is a valid version of a calculated field. And we can just double click the column header and call it age if we'd like. Stamped these values now onto the table, and we can use these age values to filter or segment the data using our pivot table. So thumbs up, that's a good example. Now let's look at a bad example. So for this one, why don't we go to the Product Lookup tab, and I'll click a cell in the Add Column, click the formula bar. In this case, what if we tried to say, let's calculate the average of the product retail price. So average of the product retail price from the Product Lookup table, and just close the formula just like that. When I press enter, just like the sum example in the slide, this returns the same average value in every single row. And now we can't break this down, we can't segment this data. It's just kind of fixed and stamped there. So not a very helpful version of a calculated column in this example. So easy to remove. You simply right click the header, delete the column, press yes, and you're back to where you started. So there you go. That's your quick primer on calculated columns.